With a couple of peerings in place, let's get ready to do some advertising of routes with BGP. And of course, we'll have to create a route or two to advertise as well. Now, we are going to use the network command in BGP, but not quite in the same fashion as we did with OSPF and with the EIGRP. The command is going to look much the same. But there's a little nit to pick here because where IGPs identify the interfaces to be enabled with the protocol in question, BGP uses this command to identify the networks to actually be advertised by BGP. Now, the network specified by the BGP network command has to be an exact match for a network contained in the IP routing table, and that includes the mask, should you include it. Because using the mask in the BGP network command, it's not required. It is highly recommended though. If you're called upon to troubleshoot a BGP config, even if it's yours, and that config is missing the masks on the network statements, that's the first thing I would check out. That is very likely the issue. You got to use the mask or you'll end up only with the classful networks, or you'll end up with no networks at all. And I have a feeling we're going to see that live as well. Now we're going to get this lab started. We're going to use the same adjacencies that we just built, and we're still using the loopbacks. And what we'll do first is advertise R3's loopback via BGP. So let's bring our live equipment up, and we will do just that. And we're going to use the network command here, and network number is the only option. So actually we'll go with 3333. And backdoor route, that's more of a CCIE level topic. We're going to leave that alone for right now. Route map, we're going to leave alone for right now to modify attributes because we haven't even covered what attributes are yet. So that kind of leaves us with mask. But do note that there is a CR here. So this is a legal command that I really recommend you put the masks in. And so does Cisco. So we'll go with the 32-bit mask because that's what we put on our loopback. And it won't surprise you that we've got some options there, and they should look familiar, backdoor and route map, but we're going to leave those alone for right now and just go with that. So what should we do now? We should go over to router 1 and see what we have for a route. And this is a new command. This is one you're going to come back to time and time again as well, and that's show IP BGP. And notice it gives you what the local RID is, and now these status codes. And we've got some origin codes there, I for IGP, E for EGP, and a question mark for incomplete. And the origin, that's an attribute, and that's actually the first attribute we're going to talk about later in this particular video. Status codes, suppressed, damped, history, and then we've got valid and best. And that's a phrase you should get used to. And of course, the last one you see there is I for internal, because that's what we're looking for. We're not going to send pings around here because that's not a true test of BGP connectivity. What we're looking for with BGP is what we call valid and best. And that's what we have to the left of that network 3333 entry. And just to extra highlight it there, we've got valid and best. It is not enough to have an asterisk next to the route. It is not enough to have the greater than sign, or what I prefer to call an arrowhead, because I call it an asterisk and arrowhead. I think that's a great way to remember it, especially if you're new to BGP. You've got to have an asterisk and an arrowhead next to that route for that to be the valid and best route. Because as we'll see in upcoming labs, and of course we want redundancy, right? If this path to 3333 goes down, we really want to have another one. Well, when BGP has multiple paths to choose from, it's going to pick one as valid and best, and it may mark the others as one or the other, but again, you got to have both. You got to have valid and best. So far we're good here. We've got our network entry, we have our next top IP address, there's a metric of 0. We're going to be coming up on how to work with that metric and something called a lock perf. And that is actually short for local preference. That's another BGP attribute we'll be working with here in this section. And wait is another BGP attribute we'll be working with in this section. And the path, you'll note 200 and then I. That's the what we call the AS path. And that's another attribute. So like I said, we're going to be coming back to show IP BGP here pretty darn often. Right now, let's go over to router 3 and have a look at what this table looks like, what this router's BGP table looks like. And you'll notice that we still have a valid and best, but a couple things to note here. We have some different status codes because we have a slightly different version here. I wanted you to get used to seeing more than one. Also note we do have valid and best next to that network entry. The next hop is all zeros because we're on the router that actually has this network on it. So there really is no next hop. And I'm sure a couple of you noticed that there's no number in the AS path, just the letter I, and there's a wait of 32,768. And you can see on the screen the router 1 part is gone, but we know that's router 1 show IP BGP at the top. And you'll notice the wait there is 0. That might just come up in our discussion of the wait attribute, but it's a good thing to note right now. Let's see what happens though if the network command doesn't quite match what the IP routing table has. And to do that, we'll go ahead and just create another loopback. And we'll call this one loopback 33, IP address 33333. And I'm going to put a 24-bit mask on it instead. But let's say then under router BGP 200, I put there we go, I knew I could do it. And a full mask, 32-bit mask. Well, when you hit enter, you're not going to get an error message. You know how I've said in a couple of courses, especially if you took the CCNA with me, I'll say, it's great because most of the time, 99% of the time when something is a little amiss, Cisco router or switch is going to give you a little hint or a little console message. Well, here we're not getting anything. But what we might get over on router 1 is a lot of nothing as well, because we don't have an entry for 33333 because that network statement is actually incorrect over on router 3. But when you put an incorrect network statement in, the router is not going to say anything to you. The router is going to say, well, that must have been what that person meant to put in there. So let's take that entry out. We'll do a Control A to move to the front of that line. Now, if I try this, I want you to see this message as well. Yeah, you'll get this and say, BGP, it's a BGP specific message, incorrect network or mask prefix link configured. And you're like, what? Huh? Well, if you put a 24-bit mask here, of course, your entry needs to be 33330. And now, let's see what we have over on router 1. And we already have that entry. And again, it's valid and best. Exact same entries for the next hop, metric, local pref, wait, and path. And it makes sense because it's a path coming from the exact same router. So we've looked at the network command, and we are going to be looking at it a lot here in this part of the course, of course. But let's go ahead and start talking about BGP attributes. I want to give you just a little bit of theory here, and then believe me, we're jumping right in. And with BGP attributes, if this did not come up on the route exam, it's going to come up on your CCIE written, it's going to come up on something. So I would have these down cold, because these are the BGP path attributes we're going to start with. We have well-known mandatory attributes. We have well-known discretionary attributes. We have optional transitive attributes. And then finally we have the optional non-transitive attribute. Oh, that's a lot. That's a lot to remember. But again, we're going to see just about every one of these in action in the course, and they will become second nature to you that way. The well-known mandatory attributes, we're going to see those throughout every lab we do. And we did just see these 3 in our show IP BGP table. The well-known mandatory attributes being AS path, origin, and next hop. The well-known discretionary attributes are local preference, local pref, or as we saw, LOCPRF, LOCPRF, and something called the atomic aggregate. Sounds dangerous, right? Like the ultimate nullifier, but it's safe, I promise you. No need for any goggles or anything like that. The optional transitive attributes are aggregator and community, and that optional non-transitive attribute, the MED, the multi-exit discriminator. It's hard not to say that on the Marvin the Martian voice, isn't it? The multi-exit discriminator. So we've got these 3 mandatory attributes. They are going to appear in all of our BGP update messages that go out to neighbors. These are the only 3 attributes that a BGP speaker has to understand, because not every BGP speaker you deal with is going to understand every BGP attribute. It doesn't work that way, unfortunately. Now, the optional attributes, they can be a bit of a pain in the butt when it comes to BGP, because again, not every BGP speaker is going to understand every optional attribute. And that's where the difference between optional transitive and optional non-transitive comes into play. A BGP path that's carrying an unrecognized transitive optional attribute will be accepted, and should that path be advertised to neighbors, the partial bit will be set and the attribute advertised to the neighbor. Now, marking an attribute is partial is really the equivalent of the advertising router saying, hey, I didn't understand this, but maybe you will, so here it is. An unrecognized, non-transitive optional attribute will not be passed on to other BGP speakers. And of course, the key there is non-transitive. It's not going to transit from one AS to another or even between speakers. With that said, and I know that's a little complicated there at the end, especially if BGP attributes are next to you or new to you, but it's really all going to become second nature to you with these labs, and we're going to start examining the individual attributes at the beginning of the next video. See you there.